Hi everyone. This video is going to look at Unit 2, page 9 on representations of functions. I already have some of the blanks filled in this time, so pause the video as you need to, that way you can fill in as we go. For the beginning part, a function rule is an equation that describes a function. You can think of a function rule as an input-output machine. Basically with this, what you put into your equation will end up giving you some value as the output. So we're inputting values and getting something out from it. X values are the input values. These are also called your domain values. The Y values are your output values, and those are called the range values. For example 1, we want to evaluate a function rule. It says if you know the input values, you can use a function rule to find the output values. The output values depend on the input values. Basically with this, we have an equation. It happens to have two variables, an x and a y, and what we're given is a set of x values that we can plug into the equation and use to solve, so that we end up getting something out of it for our y value. For example, we're looking at the function rule y equals 3x plus 4, and the first value in our table that we're going to try is -3 for x. So basically what I want to do is just rewrite my equation, but instead of putting x, I'm going to replace it with that input value that I'm trying to solve for. So I'm trying a -3 for x. And then I'll just use order of operations to get my answer here, right? So multiplication first, and then addition to finish it out. So if we try a -3 as the value for x, the y value ends up being a -5. And then we would pretty much do the same thing all the way down this table. So for each x value, we want to plug it in and solve to see what would happen for our y value. So I'm going to erase the x value that we just tried and plug in the next one so we can see what it looks like. So for the second one, we want to try an x value of -2. If I try -2, I end up getting -6 plus 4 for a total of -2. So when x is -2, y is -2. And then I'm going to clear this out and try the next input value. The next one that I want to input is a -1. So when x is -1 and I solve this, I get a +1 as my output value. When I try 0 for x, I end up getting a 4 for my output value. When I try a 1 for x, I end up getting a 7 for my y value. When I try 2 for x, I get 10 for the y value. When I try 3 for x, I get 13 for the y value. These function tables can have any value for your input to try. So this was just a small set that ranged from -3 to +3. But if someone was curious and wanted to know, what would happen if x was 100? Well, we could plug in a 100, use order of operations, and solve to see that y would be 304. So you could really plug in any input value and you'll get something out of it when you start solving. Okay, the second part says an equation could also be written with y as f of x. Basically what this is saying is that And we have different equations that might look like this with an x and a y value. But instead of seeing y, another way that you might see these functions named or represented would be with an f of x sitting here. So it's an f right next to an x that's in parentheses. Again, that's just said as f of x. And really, that could be any letter. So we're talking about g of x, h of x. It doesn't matter. These are just fancier titles, I would say, to name our functions. So you might see an equation like y equals 3x plus 4 written as f of x equals 3x plus 4 instead. It's doing the exact same thing. It just looks a little bit different. In this format, in fact, the f of x is just letting us know in particular, we're talking about a function. That's why this is known as function notation. The example it gives us here is an equation y equals negative 2x plus 1. In function notation, this would just be f of x equals negative 2x plus 1. And these say the exact same thing. It's just a different way to present our functions. The last part here says to evaluate f of x equals negative 2x plus 1 for the domain negative 2 is less than or equal to x, which is less than or equal to 2. Basically for this, just to get our table started, domain are all of our x values. So basically we're talking about numbers that go in this column right here on the table. What this setup is saying with our inequality symbols is that we're looking for all the x values that are greater than or equal to negative 2, but less than or equal to positive 2. So if I just fill in those numbers, those domain values would be negative 2, negative 1, 0, 1, and 2. We'll see more of these coming up, but for now just know that those domain values are all x values. And when it's set up as an inequality like this, we're just looking for all the numbers sandwiched between those two numbers. Right, so for f of x equals negative 2x plus 1, I'm going to set up a function table so that we can kind of see how this is working. Right, so we have our 5 x values that we're going to be plugging in. I know the equation that I'm going to be plugging them into. Oops, went a little farther on the parentheses. There we go. And I know where I want to end up, right? I'm trying to get those y values, those outcomes. So let's start with negative 2. If I plug in a negative 2 and solve, this would be positive 4 plus 1, which is 5. So when we input a negative 2, the output is positive 5. I'm going to try the same rule, this time replacing x with a negative 1. This would give me positive 2 plus 1, which is 3. So when we input a negative 1, we get a value of 3. I'm going to do the same rule, this time replacing x with 0. When I solve this, negative 2 multiplied by 0 is 0, plus 1 is 1. So when x is 0, y is 1. I'm going to do the same rule, replacing x with a positive 1. When I solve this, I get negative 2 plus 1, which is negative 1. So when I input a 1, I get an output of negative 1. And finally, when we plug in a positive 2 for x, we end up getting negative 4 plus 1, which is negative 3. So our output value is negative 3. Again, the f of x that you see here is synonymous with y. So we're really looking for those output values.